Okay, I want to make a video showing you how you do these calculations again for series, parallel, and mixed series parallel. These are all the circuits from the quizzes that I had you do. So this video is mainly for people who didn't actually remember how to do those calculations, find these values. So, okay, so let's start with the series one. So remember for series, the thing you know that there is one current for the entire circuit. So the first thing to do is to find the one current for the entire circuit. So use Ohm's law, I equals V over R. Okay, but since it's one current for the entire circuit, you will use the entire circuit's voltage, which is 12, in the entire circuit's resistance, which is 10. All right, so you wouldn't do 12 over 4 or 12 over 6. You do 12 over 10, right? Because it's one current for everything. So the entire current for this entire circuit is 1.2 amps. So everywhere in the circuit is 1.2 amps. So no matter what location you have, you'll have a current of 1.2 amps. All right. Next, it's time to find the individual voltages. So what you'll do is you use I equals V over R again, but this time individually for each resistor. All right. So for example, for this guy right here, you'll do I equals V over R for this resistor, and the I you'll use is the I you already found. So 1.2 is equal to V over 4. Solve for V. So you're just going to take that current and multiply by R is basically what you do, right? Because when you move that over there, you're going to multiply both sides by R, and you will get 4.8 volts for this guy. And notice if you do the same thing for this one, 1.2 times 6, right? Because you're going to set this up and you're going to take 1.2 multiply by 6. You should get 7.2 volts. Things to point out. The total, of course, should be the total 12. So it looks like that 12 volts split up. Notice that the larger resistor is always going to get more voltage than the smaller resistor. Okay, so the 6 guy got more voltage than the 4 guy. And it does split up proportionally. So if you want to do some sort of proportionality, that's another way to do this. All right. Although if you didn't already know the proportionality rules, don't worry about this proportionality rules. Just follow these steps I just did right here. Okay. So, and then you can confirm that yes, 4.8 plus 7.2 is 12. So these numbers are probably correct. All right. Now time to find power. Power is actually really easy. It's just current times voltage because P is equal to IV. This should be on your formula sheet. All right. So you don't have to memorize this. In fact, this formula is on your formula sheet too as well. Okay. So you just do the I times V for this guy. So this guy's power is going to be 1.2 times 7.2, which I think is 8.64. I don't have my calculator in front of me, but I think that's 8.64. And the units is going to be watts. And this guy then, of course, is going to be the same, current 1.2, but this times the voltage is 4.8. And that, when you multiply those two things together, you get, dang. I actually, you know what? I need my, I have a calculator on my phone. Oh yeah, look at that. 1.2 times 4.8, 5.76, okay. That was kind of painful, I know, for you guys. All right, so 5.76 watts, all right? So that's how you do the power part. And the last thing is energy. So you do have to know energy is always related to power because the definition of power is how quickly it uses energy. So for example, this guy right here, 8.64 watts. That means from an energy point of view, it's using 8.64 joules every second. So watt is a joule per second. All right. So from an energy point of view, then if this was on for a certain number of seconds, I think I said, actually, I don't remember how many seconds I asked for in the question. All right, but I must have given you some sort of time. So you just need to multiply this by how much time you have this on. That'll tell you how much energy you use, right? So you'll do the energy is equal to the power times the time. Whoa, that was a P. Power times the time. All right. And if you use watts and seconds, you'll get joules. Okay. So if I give you a time in minutes, you always have to convert that to seconds. Like, so for example, if I told you 2 minutes, which is what I think I gave you in the quiz, all right, you have to make sure if you're going to get joules, you have to turn those 2 minutes into 120 seconds. All right, that'll give you joules. Okay, and I don't feel like calculating that, but you guys can figure that out yourself. Now, mind you, you don't have to turn that into seconds. You can keep that as minutes. All right, if this is watts and this is minutes, this is still an energy. All right, it's just not the units of joules. So this is going to be, if this is in watts and that's in minutes, you'll get a unit of watt minutes. And that's a perfectly fine unit of energy as well. Okay, so as long as you're taking a power and multiplying by a time, you will get energy. Just the different units, you can use different units and get different units of energy. All right, so if you want joules, you need watts and seconds. If you want watt minutes, you use watts and minutes. If you want watt hours, you use watts and hours. If you want kilowatt hours, you use kilowatts and hours. Okay, so I think that sort of covers this first one. I'm going to then go on to parallel. Usually parallel is a lot easier for people, so I'm going to go pretty quick into this one. All right. So one of the things you know for parallel is that all parallel branches get the exact same voltage. If there's no resistor in the main trunk, then you know they're all going to be 12 volts. All right. So this is going to be 12 volts. 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 All right. Now, if there was a resistor in the main trunk, it's quite a bit more complicated. That's actually the lesson I haven't told you guys yet. I haven't told anybody this. This was what we're going to cover before, well, school got closed. I was going to cover this, if we were to have school. So I'm going to have a separate video showing you how you do these problems if there's a resistor in the main trunk. All right. So you should not really know how to do this yet. Well, don't expect to have known how to do this yet. But let me go back to this right here, this more simple one where there's just no resistor in the main trunk, just the 3 parallel branches. All right. So now we know it's 12 volts, 12 volts, 12 volts. Okay. And then you can find the current in each branch. So the current in each branch is going to be that branch's voltage, which in this case is 12 volts, divided by that branch's resistance, which in this case, there's only one resistor in that branch, so it's going to be 4. All right, so it's going to be 3 amps. And if you do the same thing right here, you should easily be able to see that this guy's going to be 4 amps. And this guy at the bottom is going to be 2 amps. All right, it's probably important to know exactly where those currents are, those values. Like this 3 amp right there, I'm going to highlight it and say purple. All right, this 3 amps is just in this branch right there. From there to there is 3 amps. And so this 4 amps is just in this branch right there. Okay, and this 2 amps is just in this branch right there. Although because this branch doesn't have any other junctions or anything like that, this whole branch is actually all the same. Like that, okay? Now then I asked you about the currents at A and B, you have to sort of see that, for example, right here, this green segment right there has these 2 bottom purple branches joining up to form that green one. And then in addition, when I come up to this orange segment here, this green now has another purple branch added to it to form up the A. So if you remember, the current in the main trunk is going to be the addition of all the branches below it. Okay, so this is current in A is just going to be 3 amps plus 4 amps plus 2 amps. That should give you, so this is going to be 3 plus 4 plus 2 is the current here. Let me write that. I equals 3 plus 4 plus 2. So it's going to equal 9 amps right here. Now, in this segment right here, you have to sort of see that's sort of the same in this segment right here. So this is kind of before it splits up, and this is after it comes back together again. So this is going to be the same amount. And of course, it's just going to be these 2 branches added together. Or another way you could think about it, it's like the orange current in the main trunk minus whatever flowed off in the top branch, right? So you could do whatever. We said there's 9 amps flowing through this top for the main trunk, minus 3 that branched off here, which would give us 6. Or you could think of it as these 2 bottom branches added together, which would still also give us 6. So right here, this, whoops, let me write that in green. So at location B on these green segments is going to be 6 amps, okay? So that's how you do parallel. Now to find total equivalent resistance, all right, there's 2 ways to do that for parallel. So one way, once again, is to use the total voltage and the total current. So if you use, I'm going to use orange here because that's what I use for the total current there. If you use I equals V over R, and you use always, if you're going to find the total resistance, you always want to use the total voltage, 12, in this case 12. But you always want to use the total voltage, and you always want to use the total current, which in this case is going to be the main trunk current, all right? And this is one way you can find R, right? So if you solve for R here, you're going to get 12 over 9, which as a decimal should be 4/3. I mean, well, as a fraction is 4/3. As a decimal, it's 1.33 repeating, all right? Or the other way is to use our parallel resistance formula, right? And 1 over R equals 1 over R, and each of these things I'm adding up right here is the resistance of each branch. So since I have 3 branches, I'm going to have 3 of these guys right here. So this is going to be 1 over R is equal to 1 over 4 plus 1 over 3 plus 1 over 6. All right? And if you're to solve this out, and don't forget to, don't just add these 3 together. Yes, you want to add these 3 together, but that's only going to give you 1 over R, so you have to do a 1 over at the very end. And if you do all of this, you will also get 1.33 repeating ohms, okay? And this was ohms too as well, all right? So if I saw this, I mean, you could do your fraction stuff, find the common denominator. Looks like the common denominator is probably 24, all right? But, oh, wait, common denominator is 12. Yes, that's the lowest common denominator. But, or you can just type this into a calculator. Literally do 1 divided by 4 plus 1 divided by 3 plus 1 divided by 6. Get the decimal, and then do 1 over that, and you'll get 1.33 repeating amps. Oh, ohms, sorry, ohms. All right, so that's how you find, there's 2 ways you can find total equivalent resistance. All right, things to note. Remember that this total equivalent resistance must be smaller than any individual branch, right? Because remember the rule is every time you add a parallel branch, the total current goes up, which means the overall resistance went down. So if every time I add another parallel branch and the resistance goes down, that means the total resistance has to be less than any individual branch, right? So that's a good double check, is that this resistance right here should be smaller than any one of these 3 resistor branches here, okay? So if you get something that's bigger than any one of these 3, you did something wrong, okay? All right, so let's go on to the last one, which is the combined parallel and series. So the way you're gonna break this down is, see, this is first 2 parallel branches. So for example, this is one top parallel branch. You can use the same technique we just did in the last one. This top one is going to be 12 volts in this branch. And then I can find the current in that branch is going to be I is equal to 12 over 8, correct? Okay. All right, so that top one's easy. And then this bottom one, you sort of to see, okay, this whole bottom branch also gets 12 volts, all right? It's not these individual resistors get 12 volts. The whole parallel branch gets 12 volts, all right? But then if the whole parallel branch gets 12 volts, these 2 are now in series. So now you're going to have to treat that bottom branch as like a little miniature version of this one, obviously with different resistor values, because this is 4 and 6, and this is 2 and 4 here, right? But this is still, you have to treat this as like, oh, the full 12 volts is now split between a 2 ohm and a 4 ohm resistor, just like in series. So you'll go through the same rules that you did for series, right? You find the current in that branch. You'll do 12 divided by not 2, not 4, but 12 divided by 6, right? Because there's 1 current for the entire branch. That'll give you 2 amps. And then you can use that to find the voltage for each one. So you're going to get 2 times 2 for that one, 2 times 4 for that one, right? So you're going to get the voltage for this one is going to be 4 volts, and the voltage for this one is going to be 8 volts. Notice that's how the 4 and the 8 split, or that's how the 12 splits into the 4 and the 8, right? Notice the larger one gets more than the smaller one. Everything we already knew about the series circuits from up here still applies here, okay? So that's basically these 3 different types of circuits. I'm hoping that once you understand how you do these calculations, those conceptual questions I asked in the second half of the quizzes, you should be able to answer those, or at least understand the answers to those. All right. Really make sure you understand these conceptual questions. They're very, very important. Whenever I end up giving you a test, which I'm still not exactly sure the format, what that's going to look like, but I guarantee going to ask you kind of more conceptual questions as well, not just questions about how you do these calculations. All right. Okay, well, that's all for this video, and thank you very much.